Hi friends, you are welcome to your favorite learning channel, that is Royal Learning Channel. My name is Oluwatoyin. In today's topic, we are going to talk about number and numeration in mathematics. Number and numeration. This topic is divided into about 5 to 6 groups. It is divided into about 5 to 6 groups. Under this topic, we have number basis, we have indices, we have surd, we have logarithm, we have set, and we have variation. So in today's topic, we are going to look at number basis. Then what is number basis? Number basis is the number of digits or combination of number that a system of counting uses in order to represent numbers. Or we can also define it as the counting system that uses notation. Is the counting system that uses notation. So this number basis helps us in writing what? Large numbers. For example, we have different bases. We have base 1 and base 2. There's nothing like base 1, sorry. So we have base 2. So what are the possible notation or possible digits for base 2? The possible digits for base 2 are 0 and what? And 1. 0 and 1. So to get possible digits for any number base is the number base minus 1. The number base minus 1 lesser than the number base. Minus 1 lesser than the number base. So my number base is 2. 2 minus 1 will give me 1. Then 1 and what? And 0. Don't forget that the examples of digits that we have, examples of digits are, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the combination of digits will give us what? Number. Don't forget, like I said, that number base is the combination of digits or the number of digits that a system of counting uses in order to represent number. So base 2 now, what are the possible digits for base 2? So they are 0 and 1. That is minus 1 lesser than the base. Minus 1 lesser than the base. So base 2 now, 2 minus 1 will give me 1. So all the number lesser than 1 and 1 will be the what? The notation for base 2. So let's take now for base 3. Base 3. What are the possible notation or possible digits for base 3? So 3 minus 1. 3 minus 1, that will be 2. So 2, 1, 0. So 2, 1, 0, 1, 2 are the possible digits for what? For base 2. So if you are having a number, if you are having numbers to base 2, let's take for example 1, 2, 0, 4 to base 3. So we can see that none of the number is what? Is equal to this base, neither greater than this base. So the number must not be equal to the base, neither what? Greater than the base. That is the meaning. The number must not be equal to the base, neither greater than the base. So number under base 2 will be like 1, 0, 0. That is why we always see 1 and 0, 1, 0 under what? Under base 2. Base 2. So the number appear here must not be equal to the base, neither greater than the base. Neither greater than the base. So you can see that all the numbers that we're having here are not equal to what? To the base, which is 2. Then they are not what? Greater than the base. That is the meaning. So if you have base, let's take another one, base 4. Base 4. Base 4. So what are the possible digits or the possible notation for base 4? So minus 3 from 4 and minus 1. Don't forget it's minus 1 lesser than the base. So minus 1 from 4 will give us 3. So 3, 2, 1, 0. So the possible digits or the possible notation for base 4 are 0, 1, 2, 3. So it shows that the number to this base 4 must neither be equal nor what? Greater than 4. The number to the base of 4 must neither be what? Be equal nor greater than what? Greater than 4. So let's take for example 1, 2, 3, 1, 0. So base 4. Base 4. So you will notice that all numbers, all digits that we have here are not equal, to 4, neither greater than 4. So the numbers here must not be equal to the base, neither be greater than the what? The base number. Neither be greater than the base number. Then another thing that you must be able to understand under this number base is the place value of each digit in the combination of number. You must be able to understand the place value of each digit in the combination of numbers. For example, we have 4, 5, 6, 7, and they ask you that what are the place value of 4? What is the place value of 4? The place value of 5, 6, and 7 in this number. So what are you going to use? You are going to use your method of tens and units as your place value. You use your method and tens and units to get your what? Your place value. 4, 5, 6, 7. Then 7 will be under what? Units. 6 is under tens. Then 5 is under 100. 4 is under what? 1000. So the unit is the same. If I want to convert my unit to the power of 10, is the same thing as 10 raised to power 0, because any number raised to power 0 is what? Is 1. Then 1 is a unit, that is a digit. Then tens is what? Two numbers. So under tens now, so I can use 10 raised to power 2 to represent what? To represent 10. 10 raised to power 1, sorry. 10 raised to power 1 to represent what? Tens, because 10 raised to power 1 is the same thing as what? As 10. While 100 is 10 raised to power 2. Don't forget that 100 is 1 and 2 0. Then if I want to convert it to standard word form, that will be 10. How many 0? That's raised to power 2. Then 1000 are 1, 2, 3. So it's 3 0. That's 10 raised to power 1, 2, 3. How many 0? That's raised to power. So my 1000 is now 10 raised to power what? 10 raised to power 3. So all this one will be our what? Our place value. So we can also get the place value of each digit. We can also count numbers by using the place value of what? Of each digit. So this digit now is the same thing as this 4, is the same thing as 4 times 10 raised to power what? 10 raised to power 3 plus this 5, that will be 5 times 10 raised to power what? 10 raised to power 2. Then 6 will be 6 times 10 raised to power 1. Then 7 will be 7 times 10 raised to power what? Is 0. So 10 raised to power 0 is the same thing as 1. 1 times 7 will still give us 7. So 10 raised to power 1 is 10. So 6 times 10 will give us 60. Then this 5, 10 raised to power 2 is 100. 100 times 5 will give us 500. So by the time you add all the numbers together, you are still going to come back to 4, 5, 6, 7. 4, 5, 6, 7. Then let's go back to number basis. So we have conversion of number basis from a base to another what? To another base. Now let's talk about conversion of base 10 to another base. are going to look at conversion of base 10 to another base. That is a number in base 10 to another base. Then don't forget that base 10 is also known as decimal. Base 10 is also known as decimal or denary. So you can call it denary, then you can call this what? Decimal. Base 10 is called decimal or denary. So it's the conversion of denary to another base. Conversion of denary to another base. So let's take examples. So example 1, convert 65 base 10 to base 6. Then you don't call it 65. You don't call it 65. You call it not one digits. You call it digits by digits. Because in number base we are counting what? We are counting digits. We are counting digits. So you call it 65 base what? Base 10 to base 2. So we want to convert 65 base 10 to base 2. So when you are converting a number in base 10 to another base, you divide the number by the new base. So you divide the number repeatedly by the new base until you what? Until you obtain 0. That is, until your quotient is equal to 0. Then the resulting solution will be the upward collection of the remainder, because at each stage you write your what? Your remainder. So to convert this 65 base 10 to base 2, so you use the new base, which is base 6, to divide 65. Then you continue dividing 65, and at each stage, at every stage, you write your what? You write your remainder. So let's convert base 65 base 10 to base 6. Let's convert 65 base 10 to what? To base 6. So you divide it by the new base, divided by 6. So 6 in 6 is 1. 6 in 5 is 0, because 6 cannot go in 5, 0. So remainder 5. Then 6 again. How many 6 can we get in 10? That is 1, remainder 0. So how many 6 can we get in 1? 6 cannot go in 1, that's 0. What will remain on ground is still what? Is still 1. So until your quotient is what? You stop when your quotient is what? Is 0. So the resulting solution now will be the upward collection of what? Of remainder. Will be the upward collection of your remainder. So your remainder now is your what? Is your result, is your answer. So 65 base 10. 65 base 10 to what? To base 6 will now be equal to 105. 105 base what? You are converting it to what? To base 6. You can see that none of these digits is greater than nor equal to the what? To the base. None of these digits is greater than nor equal to what? Nor equal to the base. So that is our answer for this example 1. So let's take another example. Example 2. Convert So 7054 to base 5. 7054. 7054 to base what? To your new base. That is base 5. So you divide continuously by the new base and you write your remainder at each stage. So 5 in 7 is what? Is 1. Remainder 2. So add 2 to 0, that is 20. 5 in 20 is 4. Then 5 in 5 is 1. 5 in 4. 5 cannot go in 4, that is 0. Remainder what? Remainder 4. So you divide by 5. 5 cannot go in 1, so you take 14. 5 in 14 is 2. Remainder 4. That will be 41. When you place 4 beside this one, that's 41. So 5 in 41 is 8. Remainder 1. Then in 10, that will be 2. Remainder 0. So you divide by 5 again. 5 cannot go into, so in 28, that is 5. Remainder 3. So in 32, 5 in 32 is 6. Remainder 2. So we take 5 again. 5 in 5, 1. 5 in 6, 1. Remainder 1. Then 5. Don't forget that you continue dividing until your quotient is what? Is 0. So 5 in 1. 5 cannot go in 1. 5 cannot go in 1. So 5 in 11 is what? Is 2. Remainder 1. Then 5 cannot go in 2. So since 2 is the only number here, 5 in 2 is what? Is 0. So remainder what? We are still going to have 2 on ground. Remainder 2. Then your resulting solution will be what? Upward collection of your what? Of your remainder. Upward collection of the remainder. So therefore, 7054 base 10 equal to 2112, 2112, 211204, 04. To base 1 now, we are converting it to what? To base 5, to base 5. To base 5. So that is the answer for 7054 base 10. Convert 0.154 base 10 to base 2. So this is a decimal number again in base 10. We want to what? Convert to base 2. So we multiply our decimal number by what? By base 2. So let's multiply our decimal number. That is 0.154. So you multiply it by the new base. That is your base 2. 2 times 4, 8. 2 times 5, 10. 0 carry 1. 2 times 1, 2 plus 1, that is 3. Remainder 0. So you multiply by your base 2 again. 2 times 8 is 16. You write 6 carry 1. 2 times 0, 0 plus 1, 1. Then 2 times 3, that is 6. So 2 times 6, remainder what? 0, nothing. Then you multiply by what? By 2. You multiply by base 2 again. 2 times 6 is what? Is 12. 2 carry 1. 2 carry 1. Then 2 times 1, 2 plus 1, that is 3. 2 times 6, that is what? 12. That's 2 carry 1. 2 carry 1. So, and so on. So we can write our answer out now. So it's 0.154 base 10 equal to, so our answer will be the what? The downward collection of the what? Of the whole number. The downward collection of the whole number. So our whole number is what? Is 001. So that will be dot 001. dot 001 base what? Base, we are converting to base 2 dot 001 base 2. So let's move to the combination of whole number and decimal number. Let's take one more example that has to do with combination of whole number and a decimal number. Example 3. Let's move to example 3. Convert is 0.653 base 10 to binary. Then binary means base 2. So which means that we are converting 0.653 base 10 to what? To base 2. Then this is a decimal number. So you don't divide this one by the new base like that of what? Of whole number. This is not what? Whole number. This is a decimal number. So we have decimal numbers here. So we don't divide it. So what we are going to do is that we multiply our decimal numbers by what? By the new base. So that is dot 653. So you multiply it by what? By your new base. That's base 2. You multiply by base 2. 2 times 6. 2 times 3 is 6. 2 times 5 is 10. 0, you carry 1. 2 times 6 is 12. Plus 1, that is 13. So that's 3 carry what? Carry 1. So you multiply by your base 2 again. Multiply by base 2. So 2 times 6, that is 12. 2 carry 1. 2 times 0, 0 plus 1, that is 1. 2 times 3 is what? Is 6. Remainder 0 here. So you multiply by your base again, that's base 2. Since you are converting to base 2. So 2 times 2 is what? Is 4. 2 times 1 is what? Is 2. 2 times 6 is what? Is 12. Carry what? Carry 1. So and so on and so forth. So therefore, is 0.653 base 10 equal to, so the resulting solution will be downward collection of the what? Of the whole number. The downward collection of the whole number. So you start from up, that will be dot 0.101. 0.101 base what? Base 2. So that is the answer. Then let's take another example. Example 4. Example 4. Convert 0.154 base 10 to base 2. So when you have decimal number, you don't divide. When you have decimal numbers, you don't divide. So you multiply by the base. So that will be 0.154. So you multiply by your new base times 2. 2 times 4, 8. 2 times 5, 10. Is 0, carry 1. 2 times 1, 2 plus 1, 3. So remainder what? 0. So you multiply by your base again, which is your base 2. So 2 times 8 is 16. 6 carry 1. 2 times 0 0 plus 1, that's 1. 2 times 3 is what? 6. Remainder 0. So you multiply by your base 2 again. You multiply by base 2. 2 times 6 is 12. 2 carry 1. 2 times 1, 2 plus 1, that is 3. 2 times 6, 12. That's 2. Carrying what? 1. So, and so on and so forth. So our answer now will be 0.154 base 10 equal to, so the resulting solution will be downward collection of your what? Of your whole number. Downward collection of the whole number. So you start from here. That will be dot 0.001. 0.001. So into base what? To base 2. To base 2. So that is the answer for that one. So let's look at the combination of whole number and the decimal number in base 10. Combination of whole number and decimal numbers in base 10. Convert 240.341 base 10 to octa. Octa means base 8. Base 8. So it shows that we are converting 240.341 base 10 to what? To base 8. So from this, our number, from the digits, we have combination of whole number and decimal number. So we first convert the whole number to base 10 before we convert what? Decimal number to what? To base 10. So it shows that this example is of 2 stages. So first convert 240. Convert 240 to octa. Then when you are converting whole number to what? To another base. When you are converting whole number in base 10 to another base, you divide what? You divide by the new base. You divide the number, the digits, by the new base. So 240, since we are converting to octa, then octa means what? Base 8. So you divide by 8. So how many 8 can we get into? Not possible then. In 24. 8 in 24 is 3. Then 8 in 0 is 0. Remainder what? Remainder 0. Then how many 8 can we get in 30? That is 3. 8 times 3 is 24. So that will be remainder what? Remainder 6. The remaining number is not up to 8. So the next one, how many what? How many 8 can we get in 3? It is not possible. We cannot get 8 in 3. That is 0. Then remainder what? What will still remain on ground is what? Is 3. Don't forget that you continue what? Dividing until your quotient is what? Is 0. So therefore 240 base 10 equal to what? Upward collection of what? Of your remainder will be your result. So 360 equal to 360 base what? Base 8. Base 8. Then after that, convert the decimal number. So you have converted the whole number there to what? To base 8 now. Then convert the decimal number. So convert dot 341. I've converted 240. It remains what? 341. So dot 341 to base 8. Then don't forget that when you are converting decimal number to base 8, you multiply by the new base. This is what? This is a decimal number. So when you are converting decimal number to base 8, you multiply by the new number. So that will be dot 341. So multiply by your new base number times 8. 8 times 1 is 8. 8 times 4 is 32. 2 carry what? 3. 8 times 3 is 24. 24 plus 3 will give us 27. That's 7 carry what? Carry 2. Then you multiply by your base 8 again. 8 times 8 is what? 64. You write 4 carry 6. 8 times 2, that is 16. 16 plus 6 will give us 22. 2 carry 2. 8 times 7, that is 56. 56 plus 2, that is 58. 8 carry what? Carry 5. Don't forget that you don't multiply what? Your base by the whole number. Don't multiply your base by the whole number. So let's multiply by our base 8 again. So 8 times 4, 32. 2 carry 3. 8 times 2, that is 16. 16 plus 8 times 2 is 16. Yes, 16 plus 3, that's 19. 9 carry 1. 8 times 8, 64. 64 plus 1, that's 65. 5 carry what? Carry 6. So therefore is 0.341, that is 0.341 base 10 equal to, so the downward collection of your whole number will be the answer. So dot 256 equal to dot 256 base what? Base 8. Base 8. Now we have to combine the two together to get the final answer. Since we are looking for the combination of 240.341. So our final answer now then what will be the final solution? So we are going to combine the 240 base 10, answer to base 10, then answer to what? To base 10 of the decimal number together. So therefore 240.341 base 10 will now be equal to 240 base 10. 240 base 10 is 360. Then 341 base 10. 341 base 10 is dot 256. So dot 256. So everything to what? To base 8. So that is 240.341 base 10 equal to 360.256 base 8. So this is where I'm going to stop for today. To enjoy more of this class, subscribe to Royal Learning Channel. Share the video with your friends and comment. Bye.